here will be divided in three main parts. First, we will make a small introduction about the market trends, the main challenges that the producers have to face today, and also the supporting justifications for the use of hydrolysate ingredients. Then we will talk about a little bit about what we already know scientifically that has been published about the results of the use of enzymatic hydrolysates. And then we will present a new ingredient that has been developed to attend this market demand and to bring more efficiency and productivity to the fields. We start with a very optimistic expectation for the fish market, since the global fish supply is projected to rise to 187 million tons in 2030. And only for aquaculture, we left 2011 with 63 million tons, and the expectation is 93.6 million tons in 2030. So it's an increase of 47%. Those are famous graphs if we are talking about aquaculture, and both of them are saying the same thing. We need to reduce the fish meal dependency on aquaculture. So here we have in blue the fast growth of aquaculture comparing to capture production in orange. And since the fish meal is the main protein ingredient to provide the protein source of the aquaculture feed, we can assume that the demand for fish meal is also growing and the supply is not keeping up. So it will naturally lead to price increase. That is what we are showing in the second graph. And besides the increasing prices and the volatility of prices, we also have that the availability of good quality fish meal is each time lower. And what is considered a good quality fish meal is the fish meal made with the whole fish, with less ash content. And the capture will have each time less availability to provide this nutrient for aquaculture. So we have to keep developing alternatives. Here, these two articles are representing the global trend to replace fish meal. The first one is from F3, that is the Fish Free Feed. It's a global organization to promote the feed with less fish ingredients, fish oil and fish meal. And the second one is last year's editorial from the Journal of the World Aquaculture Society. And it's also highlighting the value of alternative feed ingredients. And what really represents the change from capture to aquaculture? So we live in an environment with low density, where the fish have more availability of natural feeding to provide his nutrients and what he really needs. And then we walk to aquaculture, where we have more, each time more dense production and more need to balanced feed with high quality ingredients. And talking about high quality ingredients, what are the types of process we have available in the market for feed ingredients? So those are the three main, more common ones. First, we have the thermal or cooking process. That is basically when the raw material is subjected to high temperatures. And it's how the fish meal is produced, the poultry meal, and the conventional ingredients. It's a low cost process, but it's also very aggressive to proteins, since the digestibility and the availability of amino acids are prejudiced. Then we have the chemical hydrolysis, that can be acid or alkaline, and it's when the raw material suffers severe change in pH. And the acid hydrolysis, it's often used for flavor enhancers, but its negative point is that it leads to partial destruction of some amino acids, like the tryptophan. And at last we have the enzymatic hydrolysis, that it's very soft conditions, low temperature, low pressure, that will lead to total maintenance of amino acids and improve protein quality.
It's my turn again. So, this slide shows the two ingredients that Thais explained. Intact fish meal, common fish meal, denatured fish meal by hydrolysis, chemical hydrolysis, and hydrolyzed fish meal by enzymatic hydrolysis. To Panulinus ornatus, lobster, in initial phase. And hydrolyzed fish meal, the performance in animals fed hydrolyzed fish meal in diet were better than chemical hydrolysis or intact fish meal for this animal. Here in purple are animals fed with hydrolyzed fish meal in diets. And the animals are in stage 7-2. And animals in head fed with denatured fish meal and intact fish meal are in stage 6-2. So, hydrolyzed fish meal, we gain 2 stages. And the homogeneity of the livestock is better because in hydrolyzed fish meal, 58% animals are in this phase. And in denatured fish meal, 8.8, and the fish meal, intact fish meal, common fish meal, 1% only. And the researches speak about this result is because in animal there are many peptides, and this is good for the lobster in each of phase. This slide shows the importance of fresh raw material. Feeds made with deteriorated fish meal can impact animal performance and health. In this picture, there are raw material in deteriorated stage, tilapia byproducts. And in this graphic, show that the biogenic amines in pink salmon byproducts increase a lot along the time, and includes amines, biogenics like putrescine, cadaverine, histidine in a few hours. So, by a good fish meal, poultry byproduct meal, and mainly hydrolyzed protein is needed raw material, fresh raw material for a good product, for a good performance, for a good health of animals. Ingredients with high digestibility and low phosphorus content have a positive impact on the water quality. Phosphorus high phosphorus in diet increase a lot phosphorus excretion in the water, and the inappropriate amino acid profile in the ingredients and in the feed is bad too, because for the fish this way is very easy and increase a lot ammonium in the water. So high phosphorus ingredients plus low digestibility plus An appropriate amino acid profile is equal eutrophication in the environment. It's bad for water, it's bad for aquaculture, this situation. Low quality feed leads a low yield fish with high fat content. And in this situation, decreases the resistance in the fish. Resistance in managing, in transport. On the other hand, is needed a good feed for a good carcass. For an optimal carcass yield, high bioavailability of amino acids is necessary, because for muscle, amino acids in adequate profile is needed. Besides good ingredients, we need meet the nutrient requirement for optimal performance in animals. This book is a good reference for aquaculture, and is needed look for researches, actual researches, articles, and papers too. In Brazil, the fillet is the main product by market, local market. So it's important performance and fillet yield too. And for this species, Nilo tilapia need 20.8% digestible protein for a good performance and fillet yield too.
So, since the protein quality and quantity is essential for maximum growth, as Wilson explained, we start thinking how to produce a high-quality protein source for animal nutrition. And one way to do that is through enzymatic hydrolysis. To start, a protein is a macromolecule, usually consisting of 20 different amino acids. And the amino acid is the protein unit that has one amine group and one acid group. And the peptide bond will be the link between the nitrogen from the amine group with the carbon from the acid group. And the sequence of amino acids is what defines its biological value. When we have a protein with low molecular weight, it's called peptide. So a peptide is a protein with, some authors say, less than 8,000 Daltons. And an important thing is that the peptides may have antimicrobial, antioxidant, antihypertensive, and immunomodulatory activities. And when it happens, they are called bioactive peptides. So in this figure, we have first a figure representing a protein. And then we have that the peptide bonds are broken to create a mixture of small peptides and free amino acids. And one way to do that is through enzymatic hydrolysis. So the hydrolysis is the break through the water. And an enzymatic hydrolysis is a chemical reaction accelerated by an enzyme to produce small chains of amino acids that are the peptides. And in the animal's organism, a peptide will be more easily absorbed, and the animal will spend less energy to do that. To prove that, we have this review that has explained the recent findings about the digestive functions, and the author explains that the digestive capacity depends of two main factors. One is the animal weight, if it's an adult, a larva, or a juvenile. And the other one is the protein form, if it's an intact or a free amino acid or a peptide. Here in these two graphs, first we have the comparison between two different life stages. One with 36 days past first feeding, and the other one with 78 days past first feeding. And we can see that the black part that represents the absorbed protein will be much more significant in the advanced stages. In the second two graphs, we have different protein forms. One is an intact protein, and the other one is an hydrolyzed protein. And they were administered at the same larva stage, with 25 days past feeding. And we can see that the absorbed fraction is much higher in the hydrolyzed protein. Besides the benefit in absorption, we have that the enzymatic hydrolysis will create bioactive peptides that we have mentioned before. And this figure is representing all the experimental stage involving enzymatic engineering that defines what is the best enzyme for what raw material and which process conditions will lead to the desirable bioactivities. So the different enzyme you use will interfere in the bioactivity because it will create different sequences of amino acids. Several authors have related and proved the bioactivities of peptides. For example, in 2012, Hu and other authors have related the dipeptides tryptophan and threonine to the immunomodulatory activity, and this can be much more explored to bring benefits for the aquaculture. We also have the relation between different molecular weights and bioactivities. So, for example, we have that peptides with molecular mass between 1 and 2 kilodaltons are related to antioxidant and anti-inflammatory activities. So this opens up wide applications for protein hydrolysates.
So, for fish, hydrolyzed protein is very good. This research were made in West. If fish fed with fish protein hydrolyzed improve performance of tilapia fry in Brazil. And in this issue, we observed that 4.75% increase the performance in tilapia initial phase, dark culture. And in this experiment, we studied the muscle fibers, and with 2% inclusion in diet, we observed hyperplasia in animal in initial phase, and this can be good in adult phase, and it can increase the filatiel too, because these fibers can increase the diameters by hypertrophy. For piglets, hydrolyzed protein is good too. This research, piglets were fed with feather hydrolyzed by enzymatic method too. And the piglets fed with hydrolyzed protein is better than control diet, and is similar piglets fed with plasma. Plasma is a good and reference source of protein for animals in initial phase. For piglets is more susceptible to diarrhea, and the hydrolyzed protein is good for intestine morphology and the immunoglobulin and inflammatory factors too. Increase health in piglets. So, new research show great functional potential for chicken byproducts by enzymatic hydrolysis. Many researchers found many functional and bioactive properties. I explained about this a few minutes ago. And both byproducts can be hydrolyzed by enzymes and form products for improved feed formulations, organic soil fertilizers, and the other products with biological activities for animal nutrition, for food, for human nutrition too.
Thinking about those results, BRF has designed a new ingredient that is the chicken protein hydrolysate. So the product is the result from enzymatic hydrolysis of chicken offals, chicken liver, giblets, and meat. So this is our raw material. And after hydrolysis, all the solids are removed, so we have a final ash content really low, around 4%. And we also retire all the fat, leading to a very concentrated protein and very stability to oxidation. It's important to say that our raw material is processed in maximum 2 hours. So, as Wilson said, this is very important for ingredients. And here we have the guarantee levels. We have minimum 75 of crude protein, it's a very concentrated product. High digestibility, minimum 90% in 000. And also very low phosphorus content, less than 0.8%. We will help avoid eutrophication of water bodies. And we have talked a lot about the importance of low molecular weight peptides. And with our process, we were able to produce the chicken protein hydrolysate with almost 100% of peptides below 3,000 Daltons, in the band of more bioactivity. And after knowing and defining the molecular weight, we started wondering what are the sequences of amino acids in our peptides. So we did a peptidomic analysis and we compared the chicken protein hydrolysate with the regular poultry meal. And we have discovered that in the conventional poultry meal, we were not able to identify any peptides below 3,000 Daltons. And in the chicken protein hydrolysate, we have identified minimum 78 different peptides. So it's the same raw material, only different processes, creating totally different products. And this has offered us a huge database to know exactly the application and the results of our product. So we started the in vivo tests, and first for tilapia we have high availability of amino acids. So we have averaged 96.31% of availability of amino acids. And when we talk about balance of aminogram, we also have a very interesting product. In blue, we have the nutrient requirements of tilapia for amino acids. And in orange, we have the aminogram of our product. So we have a very high protein content, high availability of amino acids, and balanced profile of amino acids.
Now I speak a little bit about the digestibility and performance in Nile tilapia in study made in UniOeste in partnership with BRF Ingredients. I talk about the amino acids and the coefficient of the apparent digestibility of chicken protein hydrolyzed is very good for protein, energy, and the blue matter too. Above to 93%. Compared the traditional fish meal, standard fish meal, with the chicken protein hydrolyzed, we can see that the two products are very different in appearance and in composition and the biological value too. The total crude protein in fish meal is between 55% and 65%. Digestive protein is 84%, and the amino acid availability is 82%. And in chicken protein hydrolyzed, total crude protein is 75%, and digestive protein is 94%, and the amino acid availability is 96%. So this product has a good potential for use in animal nutrition. The first test was about the palatance. The palatability index of the BRF chicken protein hydrolyzed increased 10.8% compared to fish meal. In two diets, we include 5% fish meal or 5% chicken protein hydrolyzed. And the parameters evaluated was pellet consumption, vegetation weight, approximation weight, first pellet capture time to make this index. After that, we studied the performance in post-larval stage in this structure with 0 to 10% inclusion. We place fish meal, and with 2.5% of chicken protein hydrolyzed, increase 23% in average phenol weight, 8.5% in average phenol length, and increase survival too. For fry. For fingerlings is good too, because this product 2 to 4 inclusion level increase in 22.5% in phenol weight, comparing the control group. Feed conversion improved too in 2, 3, and 4% inclusion, and improvement of 40%. In adults, we observed a good result for Brazil mainly, because in Brazil this product in my region there are 25 companies for produce fillet for local market, and 2.74% of the chicken protein hydrolyzed increase the fillet yield about 6%, from 32 to 34%. And the nutrition is very important. The quality of feed for fish. And in poor nutrition, we observed the little fish situation. We need quantity and quality of feed for fish farming make money, and we have a good and big fish And this increase in performance and health is possible because the fish protein, protein hydrolysis, chicken protein hydrolysis is very good for health, for increasing in numbers of fibers and the diameters of fibers too, by hyperplasia and the hypertrophy by muscle.
We also did tests for shrimps. For shrimps in vivo tests, we also had a very high amino acid availability, average 93%, and we also have a very balanced profile from the chicken raw material. In the digestibility tests, we compared to salmon meal, that is a very high quality conventional ingredient in Brazil, and we had higher levels of digestibility for protein and energy as well. In the performance in vivo tests for shrimps, with the inclusion, we had two different treatments. One that is our control group with 20% of salmon meal, and the second treatment replacing 5% of salmon meal with 5% of chicken protein hydrolysate. And we were able to increase the final weight in 7.8% and decrease the feed conversion rate in 14.3%, so very significant numbers. We also tested for chicken as well to explore the possibilities of every species, and we compared three different treatments, control group with only vegetable sources, then inclusion of poultry meal and chicken protein hydrolysate. And the only different treatment was the chicken protein hydrolysate, with benefits in feed conversion rate and also final weight. Thinking about a great market for us, that is the Vietnam, we started doing in vivo tests here as well to attend the characteristics of the market. So we did a partnership with Nong Lam University, and we had very significant results replacing fish meal for tilapia fingerlings. So we have two control groups, one with 10% fish meal and 0% of chicken protein hydrolysate. That is our positive control group. Then we have a negative control group with no fish meal and no chicken protein hydrolysate. And then we replace 5% of fish meal for 2% of chicken protein hydrolysate. And then we replace all the fish meal for 4% of chicken protein hydrolysate. So the results have showed that we can replace 5% of fish meal for 2% of chicken protein hydrolysate, or replace all the fish meal in tilapia diets, fingerlings, for 4% of chicken protein hydrolysate. So we have two alternatives and no impact in the performance of the production. So for final considerations, we have that sustainability is the biggest driver in feed innovation as aquaculture environments are increasingly threatened. So we have to develop alternative ingredients to support the aquaculture growth. Fish meal replacement is the most significant trend in aquafeed. Extensive literature showed the benefits of enzymatic hydrolysates in the past years, but it's still a recent subject, so it's important that the producers, the universities and the companies continue to make studies about that. The optimal inclusion level of hydrolysates has to be studied and addressed to proper benefit. And also the chicken protein hydrolysate is a solution to achieve performance and functional benefits, reducing the use of fish meal. So, thank you very much. Sorry about the delay at the beginning, but thank you very much for your attention.